The first part of the chapter, you were introduced to chemical reactions, thinking about the reactants, the starting materials, and the products, the new substances that are formed. And we worked on balancing equations. Remember, our motive for balancing equations is so that what we've written in our chemical equation follows the law of conservation of mass. And so to balance, we make sure that you have the same number of each type of element on both sides of a reaction. In this part of the chapter, we're still going to be using chemical equations, but we're going to be talking about specific categories of reactions. And on this first slide, you can see that there's several driving forces that will indicate that reactants will change into products. Or another way to say that is that there will be a chemical change. So on this slide, it just lists 4 of those driving forces. And we're going to talk on the next slide about in lab, what would we see? Like what will we observe when a chemical change occurs? So the 4 things that we can identify are formation of a solid, formation of a gas, formation of water, and the transfer of electrons, which we really can't see the transfer of electrons, but we'll talk about the other ones, how we can observe it. So those are 4 of the driving forces. Now, practically, we're going to be in lab mixing several reactants, and then we want to be able to make observations about make observations that would indicate to us that a reaction had occurred. So the first one on the previous slide was the formation of a solid. So that would be one thing that we would be able to observe. And we are going to have a solid form from 2 aqueous or liquid solutions. So we will be mixing liquids, and out of that, a solid will form. Now, it might not be a solid that you would have in your imagination, like rocks or sand. Instead, we call this solid a precipitate. And oftentimes, it just looks like fine powder. Sometimes the solution will go from being clear to cloudy, and that would indicate that a precipitate or a solid formed. One of the ones that you'll be observing in lab looks like gelatin. It almost looks like jelly, but it is a solid that's forming from these 2 liquid solutions. So that would be one thing that we could observe. We can also observe the formation of a gas, which remember on the previous slide it said forming a gas is a driving force. Now, what we would observe when a gas forms is maybe bubbles, something that looks like steam. It wouldn't really be steam unless it was water, but we might see something coming off the test tube. And in certain situations, you may discover a new odor if one of the gases being released has a different odor than the original substance. Now remember, in lab, when the odors are being presented in a chemical, we don't just sniff it, but we use our hand to kind of push the air above the chemical toward us. It's called wafting. So we're not just taking a deep breath of some kind of gas. So we might see bubbles or something that looks like steam, like a vapor coming off a liquid. So that would be something we could observe. We could also observe a change in temperature. So on the previous slide, it said that water forms. And I'm thinking specifically when you react 2 kinds of chemicals called an acid and a base, they form water. And that process oftentimes is accompanied by heat. And how we would observe that is we will carefully touch the test tube that the liquids are in and see if we can't feel a warmth or some heat being given off. And another one that we might observe is a color change. So in lab, when you do your reactions, I can think of two examples. So in one case, we have copper, which is a reddish material, and it displaces silver, which we'll talk about later. So we go from having a red wire that's a solid to this kind of looks almost hair-like, and it's not bright, shiny silver. It's kind of a grayish color. And so it goes to that. So we have this color and texture change and indicating that something new is there. And if you look real closely, you'll also notice that in some of them, the solution starts out blue and it will lose its color. So we have a change in color of the solution as the reaction's happening. So we look for changes in color to help indicate to us that something new has formed. So that's another thing we can look. So in lab, when we do our reaction lab, you'll get an opportunity to think about what am I observing that tells me that something new is forming. I will make one little hint here, and that is we do have to be careful because sometimes if you're mixing a colorless solution with, like, let's say it's blue, and you mix them and the blue becomes, instead of a dark blue, a light blue, well, that might not be a reaction at all. That simply could be that you're diluting or adding something colorless, which is making the color lighter. So we don't just blanket say all color changes would be a reaction. We have to think about what we're mixing and what's going on. But still, it's a good indicator. I also want to, at this point, and I'll do it more. So colorless is a description that we use when it lacks color. So there's no color. Okay, as opposed to having a color like yellow or blue, or white. There's different colors of solutions, like it could be a reddish copper color, whatever you're observing. And then there's also something that is clear. So clear means that there are no particles in the solution. So, and what this might be in comparison is something that's cloudy, where you see particles. So colorless, that would be something like a actual color, like blue. So I just mentioned this now. I'll mention it again as we're learning about observations. It's important to remind ourselves of that. Now, there are 4 types of reactions that we're going to be discussing. On the next video, I'll discuss the first 2, combination and decomposition, and then I will discuss individually single replacement and double replacement. And my goal for all 4 is that you be able to, if I give you a chemical equation, that you identify which category it goes into. And then for single replacement and double replacement, I'm going to have you also predict the products and balance the equation. And so that will be covered in those videos. So here are 4 major categories of reactions that we're going to encounter in our class and in our lab. And so you can just see them: combination, decomposition, single, and double replacement. Oxidation and reduction is kind of even a larger category, and it overlaps some of the other ones. And it's covered in Chapter 17, so we won't be working or identifying oxidation and reduction ourselves. So this is just a quick introduction to different types of reactions and the observations we're going to be making. Now there'll be a video on the different types of reactions, and so you can look at those individually.